Now let's prove the following. We'll begin from the left hand side. So on the left hand side, we have secant of a times secant of b plus tangent of a times tangent of b whole squared. So we can use algebraic identity a plus b whole squared. When you expand it, this gives us a squared plus b squared plus 2ab. So in our case, a is represented by secant of a, secant of b, and b is represented by the product tangent of a and tangent of b. So that means we will get secant squared a times secant squared b plus tangent squared a times tangent squared b plus 2 times secant of a times secant of b times tangent of a times tangent of b. So this is the expansion of the first term minus the second term. We have secant of b times tangent of b plus tangent of a times secant of b whole squared. We're going to get negative secant squared a times tangent squared b minus tangent squared a times secant squared b minus 2 times secant of a times tangent of b times tangent of a times secant of b. So here 2 times secant of a, secant of b, tangent of a, tangent of b, that gets cancelled out. Now we are going to combine the first term and we have the fourth term. So let's combine them by taking secant squared a as the common factor. So we have secant squared a multiplied to secant squared b minus tangent squared b. Then we are going to combine tangent squared a, tangent squared b with tangent squared a, secant squared b. So let's take tangent squared a as the common factor. So this will get multiplied to tangent squared b minus secant squared b. Now we're going to use a trig identity which states that 1 plus tangent squared theta, that's equals to secant squared theta. So which would mean that secant squared theta minus tangent squared theta, that's equals to positive 1. Now in our case, we have secant squared b minus tangent squared b. That means theta is actually represented by angle b here. We're going to get secant squared a times 1 plus tangent squared a multiplied to tangent squared b minus secant squared b. So we have negative 1. This is going to give us secant squared a minus tangent squared a, this value, which is going to be, if we apply this particular property or identity, we're going to get 1, which is the expression on the right hand side. Hence we have successfully shown that the left hand side of equation is equals to the right hand side. Hence proved.